Okay, guys, I am going to try to do this if it'll work. Okay, we're going to go through some examples and some notes because the next thing that we're going to be working on in this class has to do with something that you've already looked at before, but just kind of in a different way that you haven't really looked at it before. We're going to talk about derivatives and their graphs and how just the graph can tell you about the original function. Okay, before we do that, there's a couple of things we need to fill out. So first of all, here, if f of x is increasing, then that means f prime of x, okay, then that means f prime of x is, oops, ugh. Well, let's redo that because that looks terrible. Okay, there we go. Is positive. Okay, we already know that. We've already talked about that with equations. So when f is increasing, f prime of x is positive. When f is decreasing, f prime of x is negative. Again, we've already talked about that before. When f has a critical point, f prime of x is equal to 0. Okay, or is undefined. Most of the time if we're looking at a graph, we're usually thinking where it's equal to 0. F of x has a relative minimum. F prime of x should be changing from negative to positive. F of x has a relative maximum when f prime of x is changing from positive to negative. F of x is concave upward. We're going to skip these right now. I want to skip over these and move on down. Okay, let's talk about what happens with the second derivative, and then we're going to go back. So f of x is concave upward. That means the second derivative, f double prime of x, is positive. Okay, f of x is concave downward. That means the second derivative, f double prime of x, is negative. F of x has a point of inflection. That means the second derivative, f double prime of x, changes signs. And remember, it doesn't matter which way, just changes signs. Now, let's go back up to those ones we didn't fill out yet. So if f is concave upward, we already said that means the second derivative is positive. Now, here's what you want to think about. The relationship between the first derivative and the second derivative is the same as the relationship between f and f prime. So if the second derivative is positive, that means the first derivative is increasing. So when f is concave upward, that means f double prime, the second derivative is positive, and f prime of x is increasing. So likewise, when f of x is concave downward, we said the second derivative is negative, which means the first derivative, trying to put derivative and negative together, is decreasing. Okay. F of x has a point of inflection. Let's talk about that. We said the second derivative would be changing signs. So let's talk about what that means for the first derivative. That means the first derivative would have either a relative maximum or a relative minimum. So we will just say has relative extrema. Okay, because it could be either one. It could be relative max, it could be a relative min. Okay, so here is an example of what you might see. Use the graph of f prime to list properties of f and the graph of f. So this is using the graph of f prime. We want to talk about what's happening with f. Okay, so looking at this graph, okay, we want to know where f is increasing. Okay, think about what we just said. We just said that f is increasing when f prime is positive. So take a look at this graph. This is the graph of f prime. Where is it positive? Okay, it looks like it's positive starting at 0 and around 9. It stops being positive. So f would be increasing from 0, if I could write, to 9. Because f prime, f prime is positive. Okay, I'm running out of room, so I don't want to write too big. F is decreasing, so this is the opposite now. We want to know where F is decreasing, so we're looking for where this derivative is negative. Okay, so that happens when x is less than 0, okay, and when x is greater than 9, again, because f prime is negative. Okay, f has horizontal tangents or critical numbers. Okay, think about what that means. F has horizontal tangents or critical numbers when f prime is equal to 0. That happens at 0 and 9, because that's where the derivative is equal to 0. F has relative extrema. Okay, think about what we looked for on our number line. When we had our equations, we were looking for where the derivative was changing signs. If the derivative changed from positive to negative, then we had a relative maximum for f. If the derivative changed from negative to positive, we had a relative minimum for f. So notice that at x equals 0, our derivative is changing from negative to positive. So x equals 0 is a relative minimum for f. And x equals 9, if I could write, our derivative is changing from positive to negative, so f has a relative maximum there. Okay, now we're going to get into some that's a little bit different. This is a little bit different than what we've looked at as far as number lines before. So let's talk about these. F is concave up. Okay, think about what we just said in our little notes before. F is concave up when the second derivative is positive, which means the first derivative should be increasing. Okay, so this is the graph of the first derivative given. Notice that this graph starts off increasing until it reaches that maximum point, and then it starts decreasing. We're going to call that, I don't know what, x equals 5. I wonder what. Let's see. Okay, if we're looking at this point here, yeah, let's call that x equals 5. Okay, so we could say that f is concave up where f prime is increasing, which would be when x is less than 5. Okay, and again, that was where f prime was increasing. Okay, next, f is concave down when the second derivative is negative, which means the first derivative would be decreasing, which is when x is greater than 5. Okay, because that's where f prime is decreasing. Now, last one, f has points of inflection. Okay, we said f has points of inflection when second derivative is changing sign, which means the first derivative has relative extrema. There's only a relative max, and that's at x equals 5. Okay. Now, I realize this is a little bit different because we are looking at something in a different way. We're looking at a graph as opposed to equations now. We're still using the same rules. We're just kind of looking at them in a different way. Sometimes that can be hard to get used to. So that's why I wanted to go through a video of some examples. The next thing we're going to look at is some matching. Okay, so take a look here. Match each graph with its derivative. Okay, so 2, 3, and 4 are the original functions, and a, b, and c are the derivatives. So we want to match those up. So let's take a look at number 2. Number 2 starts off increasing. Notice that we increase until around here. Okay, so that means our first derivative should be positive. Okay, then we start decreasing until around here. So that means our first derivative, I could write, should be negative. Then we start increasing again, so our first derivative should become positive again. So we need a function that's going to go positive, negative, positive for the derivative. Okay, notice that that happens with b and c. Okay, so let's talk through a couple other things. Notice that this graph, I wonder if I can change colors. That would be really helpful. Maybe not. This graph is starting out concave down. Okay, notice that we're concave down about right here. Then we switch to concave up. Okay, so what that means is, let's think about what that means. If we're starting out concave down, that means our second derivative is negative, which means our first derivative is decreasing. Okay, and then here at our point of inflection, we change to concave up, which means our second derivative is positive, which means f prime should be now increasing. Okay, so take a look at between B and C. We want one that starts out decreasing and then starts increasing. Okay, notice that that happens with C. So 2 is going to match up with C. I'll write it down here because I'm going to draw the graphs, and that's a little bit easier to see. Number 3, okay, same type of deal. Let's start off looking at increasing. We start off, look at increasing, decreasing. We start off increasing, then we're decreasing, then increasing, then decreasing. So we need 3 sign changes. We need a derivative that's going to start out being positive, then negative, then positive, then negative. There's the only one that does that is A, so 3 has to match up with A. Okay, so by process of elimination, we know that 4 is going to match up with B, but let's talk about a couple of things. First of all, the pieces of 4 are all linear, aren't they? Okay, so the slope is a constant value if we have a linear function. Okay, so notice that here we have a positive slope, so that's going to be a positive constant for the derivative. Then we have a negative slope, so that's going to be a negative constant for the derivative. And then we have another positive constant for the derivative. So that's why 4 matches up with B. Okay. All right. So here, I think this is going to be a little bit difficult to do. What I'm going to do, guys, is I'm going to upload these notes into your Google Classroom, and I would like you to kind of take a look at these. Okay, what I'll do is I'll go ahead and match these up and let you know which ones these match up with. But if you would take a second and look through that on Google Classroom, that can kind of give you an idea. What this activity has you doing is matching up the functions in column A are f of x, in column B are f prime of x, and in column C are f double prime of x. So you're matching up 3 sets of functions with their original, the derivative, and the second derivative. Okay, I'm going to go ahead and put in here which ones they go along with. 5 has first derivative C and second derivative I. 6, okay, let's see if I can move this down. There we go. 6 has first derivative E and second derivative F. 7 has first derivative A and second derivative J. 8 has first derivative B and second derivative H. And then 9 has first derivative D and second derivative G. Okay, so guys, again, I'd like you to take a look at the handout. Maybe you already printed it out before you started watching this video. Okay, I'm going to make sure to post them together. Maybe you started already taking a look at that beforehand. Please try to match those up on your own. Then you can go back and check and see how you did. Hope this was helpful. I'm going to go away from that now. Here we go. And that should be the end of this. Please, guys, please feel free to ask me if you have any questions or if there's anything that you want to talk about. Okay. And hopefully this was helpful. I'm going to send out some more videos and some more links to practice stuff for you to work with as we keep moving forward. Okay.